We'll study the interactivity of the elements in the periodic table. We'll choose chemistry, periodic table, and press run. This is the periodic table, and as you see there are different colors. Each color represents a group. For example, group number 1 are alkali metals in red. Column 2 in blue are the alkaline earth metals, and they are group 2. Group 7 in purple are halogens, and group 0 in green are noble gases. You can also know which are metals and which are non-metals. Press choose in the upper left and press on the option metals, non-metals. So a new periodic table with the new colors. Metals to the left are in blue and metalloids are in orange. Non-metals are to the right and unknowns are in pale blue. You see the metalloids in orange separating between the metals and non-metals. And you can also choose the option discovery year. So you can see when was each element discovered, and if you hover the cursor over at the element, you will see the year. For example, helium in 1895, and the same thing goes for the elements below. Copper, for example, has no data regarding the discovery year. You can also choose to know about physical properties like melting points, boiling points, or electrical conductivity. Let's try choosing the melting point. So you can see the melting point of each element when you hover the cursor over the element. You can also choose atom animation, so you can see how the atom looks and the orbits for each element. You can see also the electron distribution in phosphorus, for example. You can choose in the upper right all of the periodic table elements, or you can choose a group, and you can decide which group to the right, group 2, 3, 4, etc. Or you can choose a period, for example. A period is in the elements arranged horizontally. This is period 7, for example. You can also decide to see the ion animation for each element, for example, if it gained or lost electrons. And for example, let's see the ion animation for chlorine. Chlorine gains an electron to become Cl-. So this is its electron distribution. Or for example, sodium. Sodium loses an electron to become Na+, sodium ion. So this is how it looks with the orbits and the nucleus, and this is the distribution of electrons in shells. In addition, you can also choose particle picture, so that if you press on phosphorus, for example, you will see how its particle looks like. So you see how they are close to each other. You can also choose magnesium. You can choose any element in the periodic table. If you choose magnesium, this is how the particle looks like. In helium, they are away from each other because helium is a gas, so the particles are away from each other. And in oxygen, you will see them apart because oxygen is a gas, but each has 2 atoms because oxygen is diatomic.